Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. And here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible, of course, to the extent allowed by law, tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam P on probability. An insurance policy covers the 2 employees of ABC company. The policy will reimburse ABC for no more than 1 loss per employee in a year. It reimburses the full amount of the loss up to an annual company-wide maximum of $8,000. The probability of an employee incurring a loss in a year is 40%. The probability that an employee incurs a loss is independent of the other employees' losses. The amount of each loss is uniformly distributed on the interval from 1,000 to 5,000. Given that one of the employees has incurred a loss in excess of 2,000, determine the probability that losses will exceed reimbursements. So let X be the claim for an employee who incurred a loss in excess of 2,000, and let Y be the claim for the other employee. The joint distribution of X and Y, given that each loss occurs, is uniform on 1,000 to 5,000 intervals squared in the 2-dimensional plane. So it's a bivariate distribution that we'll need to consider. This means that we can calculate all probabilities by comparing areas because it's a uniform distribution. And here's a picture. It shows what's going on in this problem. So we have losses for X between 1,000 and 5,000, for Y between 1,000 and 5,000. And this square is where the joint distribution has positive density. And the density is uniform. The joint distribution is uniform on that. Now here we have marked that this is the line where the loss for X is exactly 1,000, and the area to the right of it with this horizontal line is where the loss exceeds 2,000. A diagonal line going through down here is the line where the sum of X and Y is exactly 8,000, and the question is, what is the probability that we end up with above that line so that X plus Y is more than 8,000? But what is that probability given that we are only in the area where X value exceeds 2,000? So given that we are in this rectangle marked here from 2,000 to 5,000 for X and from 1,000 to 5,000 for Y, what are the chances that we're in this triangle which is above the line where X plus Y is 8,000? So the probability that the total losses exceed reimbursement, which is the probability of the event that X plus Y is more than 8,000, given that X is more than 2,000, is the ratio of the area of the triangle in the right upper corner of the square 1,000 to 5,000 squared in the figure that I just showed you to the area of the rectangle 2,000 to 5,000 range for X times 1,000 to 5,000 range for Y. And that ratio is 1/2 of 2,000 times 2,000, so the area of the triangle, divided by 3,000 times 4,000. That's 1/6. However, this is conditional on the occurrence of the loss of the employee whose loss is Y, but no longer conditional on the occurrence of the loss for the employee whose loss is X, because the event considered is already conditional on X being more than 2,000, so the loss has occurred. The probability of the loss occurring is 0.40, so 40%. Therefore, the probability sought is 0.40 times 1/6. That's 2/5 times 1/6, so it's 1/15, which is answer B. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.